Okay, guys, for the half angle lesson, we've got the formulas written down. I think the very first thing that we have to be very, very, very careful about is that the plus minus in no means that they're two answers. It's either the positive or the negative, never both. And that's something that you have to be so incredibly careful about. You're never going to have both a positive and a negative. You're going to have to be very smart and determine which sign you need to choose. Notice that for both the sine half angle and the cosine half angle, they look amazingly close. They both have that square root. They both have a 2 in the denominator inside the square root. Both have a 1 and a cosine, but sine is 1 minus the cosine of A. Cosine is 1 plus the cosine of A. If you did sine over cosine, you could quickly come up with tangent. But again, this first form, strongly advise you not to use it. Two much, much easier forms are the second and the third. I'll be honest with you, I almost use the third form exclusively. I generally just use sine of A all over 1 plus cosine of A. There's no plus minus there. Well, listen, as we take a look at example 1, we're asked to find the cosine of theta over 2. Let me tell you why kids get into trouble with this half angle issue. Without a doubt, I think kids would quickly say, let me guess, it's about the plus minus. Yes, that without a doubt is the key to doing this problem. Look, they're going to tell you theta lies in quadrant 2. And I think so very quickly, we've been doing these problems for weeks and weeks and weeks. You'd say, here's theta. We could draw ourselves a little triangle. Sine is y over r. You could say here's a 4 and here's a 5. You know, you've got y is equal to 4, r is equal to 5. But hey, if you know your Pythagorean triples, you're going to know the missing side down there, of course, is what? -3, in fact, because it's an x coordinate moving towards the left, and we have a 3, 4, 5 right triangle. That's not the issue that gets kids confused if they ever get a problem wrong. You might not be surprised as we're looking back at this formula. You know, the cosine of a over 2 is plus or minus, or in this case it's theta over 2. It's plus or minus the square root of 1 plus the cosine of theta all over 2. The key issue is, what sign do we choose? And we have to do some quadrant analysis, some boundary analysis. Hopefully you saw this last year. If theta lies in quadrant 2, would you agree it's between pi over 2 and pi? Right? Work with what's called the quadrantal angles. Those are the angles made by the x and the y axis. And you're always going to say, well, I'm bigger than pi over 2. I'm smaller than pi. Your goal is to find out a new angle, what theta over 2 is. And delightfully, you're going to be able to cut theta in half much the same way you'd cut these boundaries in half. What's half of pi over 2? We'd be at pi over 4 if I cut that in half. And here, pi, if I divide that by 2, I'd be at pi over 2. Tell me about theta over 2. It's in quadrant number 1. You always have to do that quadrant analysis. You're going to take half of the boundaries that you're given to find out which quadrant your new angle lies in. Why is that so important? If I'm taking the cosine of an angle in the first quadrant, what's the sign of that angle? It's positive. Like I said earlier, it's either positive or negative, never both. Then what? We're going to say up here we'll get 1 plus, well, you just figured out the cosine of theta. Well, I forgot to write that down. You help me. Going back to the second quadrant angle, remember theta is in the second quadrant. Tell me about cosine. Cosine of theta is what? Negative 3/5. That is negative. That is negative. That second quadrant angle will have a cosine value of negative 3/5. Okay? So then what? Well, you're almost done. 1 plus negative 3/5. Well, 5/5 plus negative 3/5 is 2/5. Then you'd say, well, now I've got 2/5 divided by 2. And you can do this in an old traditional sense of, the way you first learned how to work with fractions. You'd say, well, dividing by 2 would be the same thing as multiplying by a half. You'd say, wouldn't this just work out to just, 1/5? And then this would be the square root of 1, which is 1, over the square root of 5. But it's a positive value. Okay? We doing all right with that? Okay. You don't have to show the plus sign, but I'm just being really emphatic. Here's what gets kids into trouble, though. They are thinking about the wrong angles so very often. They're like, oh, you're in the second quadrant, so I better put a negative in front of my square root. Well, remember, the negative or the positive in front of the square root are dependent on not theta, but theta over 2. So that's why we always work that out. Let's keep going. Take a look at number 2. And delightfully, they've already given us the cosine angle here. They're saying the cosine of that angle is negative 1/6. And by the way, you can, without a doubt, refer to this formula. Hopefully you know it already. The sine of a over 2 is going to be 1 minus the cosine of a over 2 in the root. And of course, it's either the plus or the minus, never both. And what's really nice right now is kids quickly are going to say, hey, I know what the cosine of a is. I'm just going to plug negative 1/6 inside that radical. And yes, we're going to do that. But there's a much bigger question at hand. Whether we take the positive of that radical or the negative. And they are telling you that angle A is in the third quadrant. Third quadrant's over here. That means angle A is between what quadrantal boundaries? It's bigger than pi. And it's smaller than 3 pi over 2. So you got to look at those x and y axes to figure that out. And then you'll say, well, I need to cut that angle in half. Well, that means cut pi in half and cut 3 pi over 2 in half. What do I get when I take half of 3 pi over 2? 3 pi over 4. What quadrant are you in if you're between pi over 2 and 3 pi over 4? You're in quadrant 2. Is that clear to everybody? So guess what sign I'm going to choose for my radical out here? Just the plus. Kids might say, why? Well, you're taking the sine right now. The sine of a second quadrant angle is positive. So I'll say 1 minus negative 1/6 all over 2. Then I just have to break that down a little bit. And let's see. Hopefully you can see that we'd get minus a negative turns to plus a positive. And 6/6 plus 1/6 would be 7/6. And real quickly, kids might say, well, wait a minute. You just said that 7 over 6 dividing by 2, it's the same thing as multiplying by its reciprocal, multiplying by a half. Yes, definitely that's the case. You'd get 7 over 12. So here we have radical 7 over radical 12. And that becomes the square root of 7 all over the square root of 12. But we could break down the square root of 12 a little bit more. What does radical 12 simplify into? 2 rad 3. So here is our positive half angle value. Okay? We doing okay? All right. Well, Tangent of x over 2. Tangent of x over 2, just want to refer to, again, what I would like to point out to you. I strongly, strongly suggest that you use either the second or the third form for the tangent half angle. You could work any of those out in all truth, and they will get you the same answer. But if I can avoid this issue about choosing the plus and the minus, I'm going to do that. So, I pointed you out there. And again, you're going to have this formula out in front. So the very first thing I want to point out to you is the tangent of x over 2 is sine of x all over 1 plus the cosine of x. No need to worry about a plus or a minus. If you know what the sine of x is and the cosine of x is, you're pretty much done. Well, we pretty much are almost done. Look, we're in the fourth quadrant. You can draw angle x right here. You could say, well, cosine evidently is your adjacent over your hypotenuse. And you could call this, your x coordinate and your r coordinate if you'd like. If you know your Pythagorean triples, what triple do we have here? 7, 24, 25. Well, that means that my y value here would have to be, careful now, negative 24 because I'm going down. Right? Now, sine of an angle would, of course, be the opposite over the hypotenuse, or the y-coordinate over the radius. And notice it is a negative. In the fourth quadrant, sine is negative. Guys, we just have one little bitty thing to finish up here. We're going to say we're going to have sine. Well, that's negative 24 over 25. 1 plus cosine, well, that's 7 all over 25. And yeah, we could break this down the good old-fashioned way like we were doing, or we could do it more algebraic. To get rid of complex fractions, what could I multiply to the top and the bottom? 25. Up on top, the 25s would cancel. You'll get negative 24. Down below, you'd have 25. Plus, over here, you'd just have 7. And 25 plus 7 would be 32. You should reduce if you can, and I believe we can. Divide out of 4, sorry about that. Divide out of 4, or actually divide out an 8, excuse me. If we divided out an 8, we'd be left with what? Negative 3/4. And then we're good to go. Okay? All right, so